In this video, I'm going to demonstrate a few basic properties of waves, and I'm going to generate a wave on a string in this simulation. So these beads represent a string. On the left end, we're going to shake it up and down. So if I just shake it up quickly, up and down, it generates a wave pulse that travels along the string. And the other end of the string, well, it just goes on forever. So the string goes out the window and then it just keeps on going forever. I can make a big wave pulse. I can make a small wave pulse. Oops, tiny one. And notice that no matter whether it's big or small, they travel at basically the same speed. And that's because the speed of the wave pulses is determined by the medium they travel in this case, the string. In particular, how much tension is there in the string, how heavy is the string. Those things determine how fast a wave moves on that string. So now what I'm going to do is I'm going to start oscillating the left-hand side regularly. So we're going to generate a sinusoidal wave. I'm going to remove all friction in the string so that it doesn't lose any energy as the wave travels. So a few things I want to point out. I'm going to pause for a moment. So how high the wave is, meaning how displaced it is from the equilibrium position. So that orange line represents equilibrium. That's where the string was before we started shaking it. So how high the wave gets, or how far it gets from equilibrium, is what we call the amplitude. Right, so it's from equilibrium to the peak of the wave. The wavelength is basically, and let me play it again. The wavelength is basically what's the distance from one peak to the next, or from one trough to the next. So really it's how far you have to go before the wave repeats itself. So that's what we call the wavelength. Now we also talk about the frequency of the wave. And the way to think about that is if you were to stand in one place, so for example, if you put a little stick figure on the left side of this wave here, and you ask, in 1 second, how many oscillations do you see? Right, so let me set this running again. So if you stand on the left side and count 1001, 1002, 1003, how many oscillations do you see? 1001, 1002, 1003, 1004. Every time it reaches, say, a maximum or a minimum, that's one oscillation. So boom, 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 boom. Every time I say boom, it's at a minimum. Boom, 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 boom. So how many times per second do you see that? In 1 second, 1001. Boom, boom. You see there's 2 oscillations for every 1 second. Boom, 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 boom. 1001, 1002. So we say the frequency is 2 cycles per second, or 2 hertz. So the unit hertz simply means how many oscillations per second you see here. So, and I could change that. So if I change the frequency, let's say to this setting, now how many oscillations per second are there? 1000, let's see, 1001, 1002, boom, 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 1001, 1002, 1003. There's 1 oscillation per second. Do you see that? So now we say that the frequency is 1 hertz. Okay, so how do frequency and wavelength relate to each other? So if I were to increase the frequency, is the wavelength going to get longer or shorter? Think about that for a second. I want you to predict, when I increase the frequency, will the wavelength get longer or shorter? Now note what the wavelength is right now, right? The wavelength is at this distance here. And now if I make the frequency higher, does the wavelength get longer or shorter? here we go. I'm gonna, I'll set it going. So I'm just gonna change the frequency. I'll triple the frequency if I can. There we go. See, now the wavelength is quite a bit shorter, right? Because there are more oscillations per second, you're going to end up fitting more of those oscillations into a given space on that string. So the higher the frequency, the shorter the wavelength is, right? So those two quantities are sort of inversely related. Big frequency means small wavelength. And conversely, if I make the frequency very low, that wavelength becomes very long, right? So that's the relationship between frequency and wavelength, which we'll discuss more in class.